Hello everyone, welcome to EnviroPioneers. In this video, we are going to explore one of the most fundamental and widely measured meteorological parameters, that is temperature. It is a key indicator of the state of the atmosphere which influence the weather pattern, climate, biological processes and even the human comfort. So the temperature is a measure of the degree of hotness or coldness of a substance or environment, and in atmosphere it refers to the average kinetic energy of the gaseous molecule. As we saw in the first lecture of this playlist, that atmosphere is vertically stratified into 5 layers based on the temperature gradient. Troposphere में we have the temperature decrease from average 15 to 18 degrees Celsius on the ground to minus 56 degrees Celsius on the tropopause. Then it remains constant up to 20 kilometer and it again increases from here to minus 2 degrees Celsius at the stratopause, and then we have the decrease of the temperature to minus 90 degrees Celsius at the mesopause, and then again temperature increases and it reaches more than 1200 degrees Celsius in the thermosphere. But when we are considering the temperature as the meteorological parameter, we are actually focusing only in this part, how the temperature variation occur in the troposphere. So temperature, it is one of the basic elements of the weather and climate, and it vary on different time scale, seasonally, daily or even hourly. If you check the weather forecast on the news channel or on the internet, you can get the forecast either hourly or it can be weekly or monthly. In any of the forecast, temperature is always mentioned with its maximum value and minimum value, and this temperature it can be reported either in Celsius or in Fahrenheit. So this air temperature data, it can be reported either as the hourly temperature or daily mean temperature or daily temperature range. So here we have the definition for each one of them. Hourly temperature, it is recorded by an observer or it can be obtained from the automated observing system that continuously monitor the atmosphere. Then daily mean temperature, it is determined by averaging the 24 hourly readings, or it can be done by adding the maximum and the minimum temperatures for a 24-hour period and dividing it by 2. तो ये दोनों तरीके से हम डेली मीन टेम्परेचर कैलकुलेट कर सकते हैं, बट मोर फ्रिक्वेंटली जो है दिस मेथड इज यूज्ड. Then we have the daily temperature range and it is computed by finding the difference between the maximum and the minimum temperatures for a day. For longer period, air temperature data can be reported either as the monthly mean temperature, annual mean temperature or annual temperature range. So the monthly mean temperature, it is calculated by adding together the daily means for each day of the month and dividing this value by the number of days in the month. Now we have the annual mean temperature. So this is the average of 12 monthly means we will be adding the mean temperature for each of the month and dividing it by 12. Then we have the annual temperature range. So this is computed by finding the difference between the warmest and the coldest monthly mean temperatures. So the mean temperatures are especially useful for making the daily, monthly and annual comparison. And these temperature ranges are also useful statistics because they give an indication of extremes, which is a necessary part to understand the weather and the climate of a particular place or any area. To examine the distribution of air temperature over the larger areas, isotherms are very important. So, here we have the definition for the isotherm. An isotherm is a line that connects the points on a map that have the same temperature. As iso, it represent equal and therm represent temperature. So here in this image, these lines are the isotherm. So all the points through which an isotherm passes, they will be having the identical temperature for the time period indicated. In this map, these points are the monitoring stations and these lines are the isotherms. So it is not necessary कि जो isotherms हैं they will be passing through the monitoring stations only, as isotherms depends on the value which we have selected for creating this map. So generally the isotherms representing the temperature differences of 5 degree or 10 degree are used, but any interval can be chosen. In this image, here we have the surface temperature in Fahrenheit. This is for this particular zone, Wednesday, 25th March 2009. And here we have the color coding for different temperature values. So these isothermal maps, they make the temperature distribution clearly visible for a particular place, and it make the areas of the low temperature and high temperature easy to identify in these maps, and also the amount of temperature change per unit of distance, that is referred as the temperature gradient. It is also easy to visualize. In this map, wherever we have the closely spaced lines or the closely spaced isotherms, they indicate a rapid rate of temperature change, while the more widely spaced lines, as we can see here and in this part, they represent more gradual rate of the change. Now we will learn about different factors that are responsible for the temperature variation in the troposphere. So here we have the controls of the temperature. So the controls of temperature are the factors that cause the temperatures to vary from place to place and from time to time. Most important cause for the temperature variation is differences in the receipt of the solar radiation at different latitudes. As we can see here in this image, that the equator, it receives more direct sunlight and it is more concentrated and it covers a smaller area, and at the polar region the this sunlight, it is in more diffuse form and the same amount of sunlight is covering a larger area. So the equator is receiving annually 2.5 times more energy in comparison to the poles. So the annual variation in the sun angle and the length of the daylight, it depends on the latitude, which causes the warmer temperature in the tropics and the colder temperature at the poles. And at a given latitude जो seasonal temperature change होता है, that is mainly because of the earth revolution around the sun, and due to that the sun's vertical rays migrate toward or away from a place during a year. So as we can see in this image, as the earth revolve around the sun, for example, if we consider this particular place, so here it is away from the sun, but as earth revolve and reach to this position, now this particular point, it is facing towards the sun. So because of the earth's revolution around the sun, seasonal temperature change occurs. But latitude is not the only control of the temperature. Apart from the latitude, there are several factors like the differential heating of the land and water, ocean currents, altitude, geographical position, cloud cover, and albedo that have a strong influence on the atmospheric temperature. So, we will learn each one of them in detail, and we'll start with the differential heating of the land and water. So, as we know that the heating of the Earth's surface, it controls the heating of the air above it. But the different land surfaces like soil, water bodies, forest, ice, they reflect and absorb the varying amount of incoming solar energy. And this in turn causes the variation in the temperature of the air above. And it has been observed that the greatest contrast is not between the different land surfaces but between the land and water. So, as we can see here in this image, on the left hand side, here we have the land surface temperature in degrees Celsius. With the blue, it is representing low value 14.3383, while the red color is representing the high surface temperature 37.5417. On the right hand side, we have the image of the same place in the visible spectrum. In this, we can see this is a river. Here we have the settlement. This is the agricultural land. At some places, we have the vegetation. At some places, it is not. Here we have the barren land. And here we have the water bodies. So when we see the land surface temperature, it can be observed that the land surface temperatures are much higher than the water surface temperature. So this variation of temperature in the land surface and the water surface, that is also responsible for the variation in the atmospheric temperature, क्योंकि जो land surface के ऊपर atmospheric mass है, that will become more warmer in comparison to the one which is above the water bodies. So wherever we have the water bodies and the land surface side by side, so land it heats more rapidly and to a higher temperature in comparison to water, and it cools more rapidly and to lower temperature than water. So the variation in air temperatures are much greater over land in comparison to the water. The surface temperature of the water it rises and falls much more slowly in comparison to the surface temperature of the land. So why do the land and water they heat and cool differently? So the most important reason is the mobility of the water. Water it is highly mobile, and as this water is heated, convection process it distributes the heat through the considerably larger mass. While in the solids, heat is transferred by very slow process of conduction. Thus, here heat does not penetrate deeply into the soil or the rock, but it remains concentrated near the surface. And as a result of the mobility of water and lack of mobility in the solids, during summer, a thick layer of the water is heated to moderate the temperature. जबकि जो लैंड है वहाँ पे बहुत थिन लेयर हीट होती है, लेकिन इसका टेम्परेचर बहुत ज़्यादा बढ़ जाता है. And during winter, the shallow layer of the rock and soil that was heated in summer, it gets cooled rapidly, while the water bodies it cool slowly, because as a very thick layer of the water it gets heated in summer, and as the water surface cools, the chilled water it becomes dense and it sinks, and it is replaced from below by the warmer water which is less dense. So on the surface we again have the warm water. As the land surface it gets heated more rapidly and to much higher temperature in summer, and it cools rapidly in winter, there is much variation in the temperature, and accordingly variation in air temperature are much greater over the land than over water. Apart from the mobility of water, another factor is the transparency. As the land surfaces they are opaque, heat is absorbed only at the surface, while in the water it can penetrate up to certain depth. It can be displayed with this example. On the beaches, the sand it feels very hot to bare feet at the midday. अगर हम थर्मोमीटर यूज करें ऑन द सरफेस द रीडिंग इट मे शो 50 डिग्री सेल्सियस. अगर वही 5 सेंटीमीटर बिलो अगर हम टेम्परेचर मेजर करें इट कैन बी ओनली 30 डिग्री सेल्सियस. But in the sea water, on the surface, it will be 25 to 28 degrees Celsius, lesser than the sand. But अगर हम इसमें थोड़ा और डेप्थ पे टेम्परेचर मेजर करते हैं तो टेम्परेचर डिफरेंस विल बी वेरी लेस इन कंपेरिजन टू द surface, because the land surfaces are opaque, so the heat it is mainly concentrated only on the surface. Third factor is the specific heat. This is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius, and the specific heat of water is 3 times greater in comparison to the land. Therefore, more heat is required to raise the temperature of the water. Fourth factor is the evaporation, that is the cooling process. So evaporation from water bodies is greater than from the land surfaces. So energy is required to evaporate the water. So अगर जो भी energy इस water surface पे fall कर रही है, and if it is used for the evaporation, so it is not available there to raise the temperature of the water body. So collectively, mobility, transparency, specific heat, and the evaporation process, all these factors, they cause the water to warm more slowly, store greater quantities of the heat, and cool more slowly than the land. The moderating influence of water may also be demonstrated when the temperature variations in the northern hemisphere and southern hemispheres are compared. The views of the earth they show the uneven distribution of land and water over the globe. In the northern hemisphere, we have the water covering 61% and land is 39%, while in the southern hemisphere, water covers 81% and land is only 19%. Thus, this southern hemisphere is also referred as the water hemisphere. And due to this reason, the northern hemisphere it tends to be warmer overall and experience more extreme temperatures than the southern hemisphere due to the larger proportion of the landmass which heats and cools more rapidly than the ocean which dominate the southern hemisphere. Another factor that affect the temperature variation in the troposphere is ocean current. Above the ocean, as this wind blows, energy is passed from the moving air to the water through the friction, and the resulting drag exerted by this wind it causes the surface layer of the water to move. Thus, due to this reason, in the ocean, surface currents are set in the motion by the wind. And if we see the major horizontal movements of the surface water, they are closely related to the atmospheric circulation. And this atmospheric circulation is actually driven by the unequal heating of the earth by the sun. When we study the energy budget for the entire earth, in that case, incoming radiation is equal to outgoing radiation. Means the gains in solar energy it equals to the losses of heat radiated from the surface to the space. But when we consider individual latitudes, then there is net gain of energy in the lower latitudes and a net loss at the higher latitudes. So here in this image we can see on the x-axis we are having the latitude and here we have the energy. Here we have the equator and this is representing 0 to 90 degree north and 0 to 90 degree south. And this red line is representing the absorbed solar energy while this green line is representing the emitted IR energy. And in this image we can see that more energy is absorbed near the equator than emitted, while more energy is emitted near the pole than is absorbed. But as we see, the temperature of the tropics and the polar region is nearly constant throughout these years. So there must be large scale transfer of the heat from the area of excess to the area of deficit. Means this is the area of excess which is represented here as the surplus and here we have the area of deficit. So this transfer of heat from the equator to polar region, it is mainly done by the wind and the ocean current, and it equalizes these latitude energy imbalances. And when we consider both wind and ocean current, then this ocean water movement it accounts for about a quarter of this total heat transport, and remaining three-fourth is done by the wind currents. These ocean currents they act like a conveyor belt which transport the warm water and precipitation from the equator towards the pole and bring the cold water from the polar region back towards the tropics. Because as this warm water moves towards the pole, this cold water in the polar region it sinks and is transported towards the tropical or the equatorial region. So here we can see in this image we have the shallow warm current, means this warm water it moves in the upper layer of the ocean, and here we can see this blue line is representing the deep cold current, means cold water it moves at the greater depth. And these ocean currents they have the significant impact on the regional air temperature as they transfer a large amount of heat across the globe, with warm currents warming the coastal area and cold currents cooling them. Another factor affecting the temperature variation is altitude. As we saw in the troposphere, temperature decreases with increase in the altitude, and this decrease is on average of 6.5 degrees Celsius per kilometer. With this value, here is the explanation that how temperature falls as we move up in the altitude. Here on the sea level, we are having temperature 30 degrees Celsius. But as we move 1 kilometer above in the altitude, 30 minus 6.5, here we have the value 23.5 degrees Celsius. Again, if we move above 1000 meter, means 1 kilometer more, 23.5 minus 6.5, temperature will become 17 degrees Celsius. Likewise, when we move again 1000 meter above in the altitude, here the temperature is 10.5 degrees Celsius. So as we move above in the altitude, temperature decreases, and this is the reason that some mountain tops are always covered with the snow, as we can see in this beautiful picture. And this temperature decrease with altitude is the reason that cities at the higher elevation, they have lower average temperature. For example, Shillong or Shimla in India, they have the lower average temperature in comparison to the Delhi or the nearby places. Elevation or altitude not only affect the average temperature of a particular place but also the daily temperature range. As we move above in the atmosphere, with height, not only temperature decreases but also the atmospheric pressure and density decreases. So, because of the reduced density at the high altitude, the overlying atmosphere it absorbs and reflects only a smaller proportion of the incoming solar radiation, and due to this reason intensity of the solar radiation it is more, which results in rapid and intense daytime heating, and in night cooling is also at the faster rate. Thus the observing stations which are located high in the mountains, they generally have the greater daily temperature range, means high day temperature and low night temperature, than the stations which are at the lower elevations. Geographic position also affect the temperature. Whether we are at the windward side or at the leeward side, we will observe different temperature. Mountains, they not only act as the barriers to the airflow, but they also influence the temperature in other ways. The air which is coming from above the ocean, that will be cool and moist, and as this cooling and moist air ascend over the mountain, it will observe a decrease in temperature, and due to this reason here we'll be having the cloud formation and rain. So after rain, this air it becomes dry, and on the opposite side this air descends towards the ground and becomes warm during the process. So on the windward side, that is the upslope side of the mountain, it is generally cooler, while the leeward side, that is the downslope, it tends to be warmer. Here we have one word, rain shadow. So this rain shadow is an area of significantly reduced rainfall behind a mountainous region. Next control is the cloud cover and albedo. Have you noticed that clear days are often warmer than the cloudy ones? And the clear nights are generally cooler than the cloudy nights. This cloud cover is very important because it influences the temperature in the lower atmosphere. Many clouds they have the high albedo and they reflect a significant portion of the sunlight. And this albedo of the cloud it depends on the thickness of the cloud cover, and it can vary from 25 to 80%. During day when we have the clear skies, all of the sun's heat it is reaching to the earth's surface, but when we have the cloud cover, a portion of this radiation is reflected towards the space. Thus due to reflection the amount of incoming solar radiation is reduced, and the daytime temperature is lower in comparison to the days having the clear skies. But during night, these clouds they have the opposite effect. In the clear skies, all of the heat which is emitted from the Earth's surface that will escape towards the space. But in the presence of the cloud cover, this outgoing Earth radiation means the energy emitted from the Earth that will be absorbed by these clouds, and they will emit a portion of it back towards the surface. And due to this reason, the clear nights are more cooler in comparison to the cloudy ones. And the effect of the cloud cover is to reduce the daily temperature range because it lowers the daytime maximum and it increases or raises the nighttime minimum. Snow and ice also influence the temperature variation because the snow and ice covered surfaces they have the high albedos. So incoming solar radiation is reflected by this snow and it is lost into the space rather than absorbed by the ground and heating the lower atmosphere. As we can see here, we have the comparison of the surface without snow or ice, and here we have the surface with snow and ice. So this part we can see that 85 to 90% is reflected and only 10 to 15% is absorbed. While on the left hand side, 70% is absorbed and only 30% is reflected. So when more energy is absorbed by the ground will become heated and the atmosphere will become warm. And due to this reason, when a ground is covered with the snow, the daytime temperature is less in comparison to the normal days. Large portions of the Arctic Ocean, it is covered by ice, that is the frozen sea water which floats because it is less dense than the liquid water. Here we can see the difference in the albedo of the snow and ice covered water and the water without snow and ice. Here we are having the reflectance 90%, while when we are having only water, this is 6%. So over the years, the area which is covered by the sea ice is shrinking. Thus, the broad zones that were once covered by the highly reflective ice that are being replaced by the darker ocean surface which reflects less and absorbs more. Here also it is mentioned that the bright white snow or ice, it reflects the majority of the incoming sunlight and absorbing only a small amount of heat. And wherever we have the darker ocean surface, it absorbs a much larger proportion of the heat coming from the sun. And the lowering of albedo in the Arctic is contributing to the rising temperature in this region. Apart from the natural factors, cities or the built up environment also influence the temperature. And associated to this, we have a term urban heat island. That is a phenomena in which the built environment it alters a city's air temperature. As we can see in this image, here we have the commercial, city, urban, residential, and park. And this side we have the suburban area, and here we have the rural farmland or the rural areas. And this red line is representing the late afternoon temperature in degrees Celsius. And we can see that the temperature is maximum in the city area or in the built up area. So this phenomena where a built up environment is having the more temperature in comparison to the nearby suburban or the rural areas, this is referred as the urban heat island. So the construction of the factories, buildings, roads and the houses, it creates a new microclimate of the greater complexity because the changes in the way a city absorb and emit the radiation, it generally increase the temperature in comparison to the surrounding rural areas. Because in the cities, large buildings along with the concrete and the asphalt parking lots, they absorb and store greater quantities of the solar radiation in comparison to the trees and the farmland in the rural areas. During night, when all the places cool by the radiative losses in the city, the stone-like surface they gradually releases the additional heat which is accumulated during the day. Thus, they keep the urban air warmer in comparison to the suburban and the rural areas. Now, coming to the cycles of air temperature, which represent how this temperature vary with time. So, there are two basic cycles of air temperature: daily temperature cycle and the annual temperature cycle, which is associated with the seasons. Daily temperature cycle it represent how this temperature vary or fluctuate in the 24 hours. Here in this image, we can see on the x-axis, we have the time. So we are starting from the 12 midnight. Here we have 2 a.m., 4 a.m., 6 a.m. that is representing the sunrise. Here we have this noon and sunset. And here again we have the 12 midnight. So this is representing 24-hour cycle. And on the y-axis, here we have the energy rate, and on the upper side we have the temperature. So this daily temperature cycle, it represents the rhythmic rise and fall of the air temperature every day. We can see that the temperature it reaches a minimum around the sunrise, that is the 6 a.m., and after that it is increasing and is reaching the maximum in between 1 p.m. to 4 p.m., and after that it is again declining until the sunrise the next day. The primary reason for this daily temperature cycle is the rotation of Earth on its axis, which causes the day and night on the Earth's surface. From the sunrise to the sunset, we receive the solar radiation. So, this part is representing the incoming solar energy, and the blue line is representing the outgoing Earth energy. And at this point, incoming energy it equals the outgoing energy. If you notice, the Earth receives maximum solar radiation around noon, but the maximum air temperature is around 4 p.m. So the time of highest temperature it does not coincide with the time of maximum radiation. Here comes the concept of the net radiation. Net radiation is equal to incoming solar minus outgoing IR, and this net radiation it determines whether the surface temperature will rise or it will fall or it will remain the same. So if the net radiation is more than 0, the surface it become warms. So it is generally in between 6 a.m. to 3 to 5 p.m. But if the net radiation is less than 0, in that case surface cools, and that mainly happens in between 3 to 5 p.m., means from here to 6 a.m. So, as long as the solar energy gained it exceeds the rate of earth radiation lost, the air temperature will continue to rise. As we can see from 6 a.m., this temperature is continuously rising. But the time of highest temperature it is not coinciding with the time of maximum radiation, and this is referred as the lag of the maximum, and it mainly happens because of the process by which the atmosphere is heated. As we know that the air is the poor absorber of the incoming solar radiation and is mainly heated by the long wave IR radiation emitted from the earth's surface. As in this image we can see the temperature is continuously increasing because of the absorption of the heat by the earth's surface, but at this point here we are having the maximum outgoing terrestrial radiation, means the atmosphere is already warm plus it is receiving the outgoing terrestrial radiation which is absorbed by the atmosphere, and at this particular time the atmospheric temperature is maximum. Annual temperature cycle it represents the variation of temperature for different months. Here in this image we have the earth's average temperature starting from 1850 to 2023, and for all these years the trend is nearly similar, means we have the maximum temperature in the July and August and the minimum temperature in the January and February. So in most years the month with the highest and the lowest mean temperature it do not coincide with the period of the maximum and the minimum incoming solar radiation. So to understand this we have the explanation here that in the northern hemisphere the greatest intensity of the solar radiation it occurs at the time of the summer solstice in the June, yet the month of the July and the August they are generally the warmest of the year in the northern hemisphere, and the least amount of solar energy is received in December at the time of winter solstice, but January and February are usually colder. So, the occurrence of annual maximum and the minimum radiation it does not coincide with the times of temperature maximum and minimum. It indicates that the amount of solar radiation received is not the only factor determining the temperature at a particular location. All other factors which we studied, like the land and water, ocean currents, altitude, geographic position, cloud cover and albedo, snow and ice, they also play a very important role in determining the temperature. Next subtopic is the temperature measurement, means how we measure the atmospheric temperature. So for this we mainly use the thermometer. Thermometer is an instrument which measures the temperature. So within name, meter means measuring and therm means temperature. So these thermometers can measure the temperature either mechanically or electrically. So accordingly, they are referred as the mechanical thermometer or the electrical thermometer. So we will start with the mechanical thermometer, which works on the principle that different substances they react to temperature changes differently. Means most substances expand when heated and contract when cooled, and many common thermometers are based on this property. So, the most common one is the liquid in glass thermometer, which provides relatively accurate reading over a wide temperature range. So, this liquid in glass thermometer, it was developed in the late 1600, and its design, it consists of a bulb containing a fluid and a stem that has been bored to form the capillary tube. When temperature rises, the molecules of the fluid they grow more active and they spread out, which causes the fluid to expand, and it forces a thin thread of the fluid up in the capillary tube. And when the temperature fall, this liquid it contracts and the thread of the fluid it moves back towards the bulb. End of this thread it is referred as the meniscus, and the movement of the meniscus is calibrated against an established scale to indicate the temperature. Within the mechanical thermometers, we have the maximum and minimum thermometer, which are specially designed liquid in glass thermometers that can measure the highest and the lowest daily temperatures. So here we have the maximum thermometer and this is the minimum thermometer. So maximum thermometer is the thermometer which can measure the maximum temperature for a given period in time, usually 24 hours. And the minimum thermometer is the thermometer which measures the minimum temperature for a given period of time, that is also 24 hours. So let us see what is the difference between these two. So maximum thermometer, in this liquid mercury is used, and in this thermometer the capillary tube is narrowed down just above the bulb, and this is referred as the constriction. So as the temperature rises, the mercury will expand and it forced through this constriction. So it will rise and will reaches to the maximum temperature. But when the temperature falls, then in that case, this constriction it prevents the mercury from returning back to the bulb. So as a result, the top of the mercury column it remains at the highest point, which represent the maximum temperature attained during the measurement period. And this thermometer or this instrument it can be reset by the shaking or whirling, which force the mercury to reach back through the constriction, and it should be completed before the next measurement. In the minimum thermometer, instead of mercury, alcohol is used, which is a liquid of low density. And within this alcohol, we have a small dumbbell shaped index which rests at the top of this column. Okay, as the air temperature drops, ये जो column है that will shorten and the index will be pulled towards the bulb by the surface tension of the alcohol meniscus. But as the temperature rises, the alcohol will flow above the index, leaving it at the lowest temperature reached. And as this index is free to move, this minimum thermometer it must be mounted horizontally, otherwise this index will fall at the bottom. And to return the index at the top of the alcohol column, this thermometer is simply tilted. So we can see this index it is showing as the minimum temperature and the liquid it is showing the current temperature. Another type of mechanical thermometer is the bimetal strip. This thermometer it consists of two thin strips of the metal which are bonded together and have widely different expansion properties. So when the temperature change, both the metals will expand or contract, but they will do at the different rate, and it causes the strips to curl. And this change it corresponds to the change in temperature. And these bimetallic strips they are often used in the home thermostats or the thermographs. As we can see here in this image, here we are having the colder temperature and this is the bimetallic strip. Pointer is at the 0. But when this bimetallic strip, it observes the change in temperature, means towards the heated condition, the copper strip, it expands in heat, while the inward strip, it expands less than the copper. So depending upon the temperature, expansion of copper will occur in this bimetallic strip and it will rotate, and we can see this pointer is moving towards other direction. So it will depend upon the temperature in that particular area. So here it is mentioned inward strip. So inward strip is a thin flat piece of an iron nickel alloy. It is referred as the inward, and it is known for its extremely low coefficient of thermal expansion, means it changes very little in length with the temperature changes. Another type of thermometer is the electrical thermometer. Most of the modern observing stations, they are automated and they use the electrical thermometers to measure the temperature. A resistor is a small electrical part which registers the flow of electric current, and a thermistor, which is the thermal resistor, it is similar to it, but in this case resistance to current, it varies with the temperature. So a thermistor works on the principle of temperature dependent electrical resistance using the semiconductor materials whose resistivity changes significantly with the temperature. There are two type of thermistor: NTC, that is the negative temperature coefficient thermistor, and PTC, that is the positive temperature coefficient thermistor. So in NTC, as the name suggests, negative temperature coefficient, resistance, it decreases as the temperature rises. So it is generally used when a change in resistance over a large temperature range is required. So it is used as the temperature sensor in the range of minus 55 degrees Celsius to 2200 degrees Celsius. And for making this, mainly cobalt, nickel, iron, copper and manganese are used. While the positive temperature coefficient thermistor, as the name suggests, the resistance increases with temperature, and it is mainly used when a sudden change in resistance at a specific temperature is required. So mainly it is used for a defined temperature range of 60 degrees Celsius to 120 degrees Celsius, and for making this, barium, strontium and the lead titanates are mainly used. So for atmospheric temperature measurement, mainly negative temperature coefficient thermistors are used because of the wide temperature range, and they have the high sensitivity, accuracy and the fast response time. Whether we are using the mechanical thermometer or the electrical thermometer, the accuracy of the temperature measurement not only depend on the design and the quality of the instrument, but also on where they are placed. Because if they are placed in the direct sunlight or near a heat radiating surface, or if the air is prevented from moving freely around the thermometer, in that case we will be getting the inaccurate reading. So the temperature measuring instrument should be placed in the instrument shelter. This instrument shelter, it is commonly known as the Stevenson screen. It is a ventilated white enclosure which protects all meteorological instruments from the direct sunlight and the precipitation, and allows for the accurate reading for the meteorological parameter. And these instrument shelters should be preferably placed over the grasses and far away from the buildings. And the shelter must have the standard height so that the thermometers are mounted at 1.5 meter above the ground. And this is the standard height for the atmospheric temperature measurement above the earth's surface. As temperature, it indicates the hotness or the coldness. So for quantitative measurement of the temperature, scales are established. So next subtopic is the temperature scales, and these scales are based on the use of the reference point or fixed point. So mainly three type of scales are there: Fahrenheit scale, Celsius scale and the Kelvin scale. We will learn the difference between them, and we'll start with the Fahrenheit scale. In 1714, Gabriel Daniel Fahrenheit, a German physicist, he devised a temperature scale and named after his name, Fahrenheit scale. So he constructed mercury in glass thermometer in which the 0 point was the lowest temperature which he attained with the mixture of the ice, water and the common salt. And the second fixed point he chose was the human body temperature. But these values were modified with time, and the present Fahrenheit scale is defined by two fixed points, ice point and the steam point. Means ice point, the temperature at which ice melts, and the value is 32 degree Fahrenheit. And the steam point is the boiling point of the water, and the value is 212 degree Fahrenheit. And the difference between two fixed point on the Fahrenheit scale, means ice point and the steam point, it is 180 degree. Next is Celsius scale. In 1742, 28 years after the Fahrenheit invented his scale, Anders Celsius, a Swedish astronomer, he devised a decimal scale on which the melting point of ice was set at 0 degree and the boiling point of water at 100 degrees Celsius. Means ice point was 0 degree and the steam point was 100 degree. Now the interval between the ice point and the steam point is 100 degree on the Celsius scale, while it is 180 degree on the Fahrenheit scale. So Celsius degree is larger than the Fahrenheit degree. And by how much? So it is by a factor of 180 divided by 100. So that is 1.8. So to convert from the Celsius scale to Fahrenheit scale or vice versa, allowance must be made for this difference in the size of degrees, and also the conversions must be adjusted, because in the Celsius scale the ice point is 0 degree while in the Fahrenheit scale it is 32 degree. So the Celsius Fahrenheit relationship is degree Fahrenheit is equal to 1.8, which comes from here, into degree Celsius plus 32. And if we want to calculate degree Celsius from Fahrenheit, so here we have the formula degree Fahrenheit minus 32 divided by 1.8. Next is the Kelvin scale. So for scientific purpose, a third temperature scale is used, the Kelvin or the absolute scale. And on this scale, degrees Kelvin are called kelvins, which is abbreviated as K. Now, this scale is also similar to the Celsius scale because its division are exactly the same. 100 degree separating the melting point of ice and the boiling point of water. But on the Kelvin scale, the ice point is set at 273 and the steam point is at 373. In the science, the 0 point, it represents the temperature at which all the molecular motion is presumed to cease, and it is referred as the absolute zero. Thus, in the Kelvin scale, there is no temperature lower than absolute zero, like Celsius and Fahrenheit, where we have the negative values. So, if we want to convert from Kelvin to degree Celsius, so here we have the formula. Degree Celsius is equal to Kelvin minus 273, while if we want to convert the temperature from Celsius to Kelvin, we have to simply add 273 in the this value. Now again, if we see this image, it will be more clear. Here we have the Fahrenheit, Celsius and the Kelvin. Ice point is the 32 Fahrenheit and steam point is 212 Fahrenheit, and the interval between these two is 180. While in the Celsius and the Kelvin scale, the interval between the ice point and the steam point is 100 degrees, and here also. But in the Celsius scale, ice point is 0 degree and steam point is 100 degree, while in the Kelvin scale, ice point is 273 Kelvin, while the steam point is 373 Kelvin. 0 Kelvin, it represents the absolute zero, while in the Celsius and the Fahrenheit scale, we have the negative values. At the end of this video, we have several definitions to remember. These two are the indices for the human discomfort. Wind chill, it is the perceived decrease in the air temperature felt by the body as a result of the flow of air. And the heat stress index, it is the perceived increase in temperature which is felt by the body as a result of humidity. And the heat wave. It is a period of abnormally hot and usually humid weather which typically lasts from a few days to several weeks. So you can memorize these three definitions, and these are the references, and this video is basically the explanation of the chapter temperature in this book, The Atmosphere and Introduction to Meteorology, and some part have been taken from this particular website, and the reference to all the images have been mentioned in the video itself. We will meet soon in the next video related to next meteorological parameter. Thank you and best wishes.